This video goes through direction, compass and true bearings. Now you're going to sketch compass and true bearings and you're going to solve problems using compass directions and also true bearings. So our skills interpret, sketch, calculate and solve, and you'll hopefully be able to apply your knowledge to correctly complete the set questions. So let's begin by looking at the two methods of giving directions. Now, the compass direction method uses the compass directions north, south, east, and west, which you should be familiar with. The most important thing is that they should be given from north or south. So you're either going to go north, which way, or south, and then which way. Do not start at east or west. Now, the true bearing method is the angle turned in a clockwise direction from true north. Okay, now it's traditional to use 3 digits when describing a bearing as well. So let's look at some examples. The first one here, we have this angle 73. So for a compass direction, we are closest to north, right? So we're going to start with north. From north, we know to go 73 degrees towards east. So the compass direction is north, 73 degrees east. For a true bearing, you start at north and you go in a clockwise direction and you are going 73 degrees. For our true bearing, then, it's just 0, 73 degrees. T for true. Looking at the next one, now we're closest to south. So for our compass direction, it's going to be south. From south, we need to go 25 degrees towards west. So that is our compass direction. Now for our bearing, we need to start at north and we need to go in a clockwise direction down to that line. So what we have to think about is we're going to go 180 degrees here plus that extra 25 degrees. So our true bearing is 180 plus 25, which is 205 degrees. So we're 205 degrees true. Next, now we are closest to north, so it's going to be north. Now from north, you have to go this way, but we don't have that angle. But that angle will be our 90 degrees, the full amount, minus 35. So so 90 minus 35, which is 55 degrees. So it's north, 55 degrees, and we're going towards west. For our true bearing, we have to start at north, go in a clockwise direction all the way around. Okay, so you have two options here. You can go the full 360 degrees and minus that 55 degrees you just found, which will be 305 degrees. So 305 degrees true. Your other option is that this angle here is 270 degrees. So you can go 270 plus 35, which is also 305 degrees. State the direction and bearing of P, Q, and R from O as shown in the diagram. You are going to be given 3 minutes to have a go at as many of these as you can do first. Remember, you are doing direction and bearing. P is closest to north. So for our compass direction, we're going to start at north. We need this angle here. That angle there is going to be the full 90 degrees minus 10, which is 80 degrees. So we've got north, 80 degrees, and we're going towards east. So that is our compass direction. Our bearing for this one, we now have. We start at north and go down to point P. So our so our bearing is 0, 80 degrees true. Okay, so now let's do Q. Q is closest to south, and we need to go from south towards west. So we need this angle here, which is going to be 90 minus 35. So that's 55 degrees. So we start at south and we go 55 degrees towards west. Now for the bearing, we're starting at north and we have to go all the way around. Now we know that 3/4 of the way around is 270 degrees. So one option is we can go 270 minus the 35 and we get 235 degrees. Our other option is to use the angle we just found and know that the straight line's 180 degrees and we have to go an extra 55 degrees. So either way will get you that 235 degrees. Then R is closest to north. So north, and we have to go 25 degrees towards west. So that's a nice easy one. I'm going to take out all my working out for that last one. So for the bearing, we need to start at north and go all the way around to there. Probably the easiest option is to do the full revolution of 360 minus 25 degrees. And that would be 335 degrees. So we have 335 degrees, true. You now have 123 seconds to do the next one. And go. Okay, let's start at P. Compass directions closest to south. So I start at south and I have to go 30 degrees towards east. It's a nice straightforward one. For my bearing, I need to start at north and go down to P. So easiest option there would be to go 180 minus 30, which is 150 degrees. 150 degrees, true. For Q again, we need to start at south and we need to go 50 degrees towards west. So south, 50 degrees west. For our bearing, we need to start at north and go all the way around. So that's going to be the 180 plus 50 degrees, which is 230 degrees. So 230 degrees, true. For my last one, R is closest to north and I need this angle here. Now that angle there is going to be 90 minus 85 degrees, so that's 5 degrees. So I start at north and I go 5 degrees towards west. And for the bearing, it's easiest to use that angle I just found because I need to start at north and go all the way around. So if I go 360 minus 5 degrees, that's 355 degrees. True. Okay. So let's move on to some application questions of bearings. First one, a cyclist travels in the direction north 30 degrees west until he is 10 kilometers north of his starting point. Okay, so let's draw our compass rose. Now I know I'm going north 30 degrees west. So I know I'm going off to the left. So I'm drawing my compass rose so I can do that. Now, north 30 degrees west. No, this is west. No, that was north. So there's my 30 degrees, right? So my cyclist is maybe at this point. Doesn't really matter. Now it tells me, so that's my north 30 degrees west, until he's 10 kilometers north of his starting point. So if I drop a line down to that compass rose, that's telling me that this here is 10 kilometers because he's 10 kilometers north of his starting point. That's his northerly direction. And what we need to find is how far he's traveled. So that's my X there. So what you should see is this nice right angle triangle here. Your other option is you could draw your triangle in this way. Doesn't really matter. I'm going to go here and I'm going to work that one is 90 minus 30, which is 60 degrees. So I have that that's 60 degrees. I'm going to label my triangle hypotenuse opposite, adjacent. I have my opposite. I want my hypotenuse. You can use your formula sheet, or you can remember SOHCAHTOA. O and H is sine. So I write out my ratio. Sine theta is O over H. Sine 60 is opposite, which was 10 over x. I need to swap those. So x becomes 10 over sine of 60. Go to your calculator. 10 divided by sine of 60 is approximately 11.55. And it's going to be kilometres. Finish with a therefore statement. Therefore, the cyclist is 11.55 kilometres north of his starting point. Nick cycles 15 kilometres due north, then 12 kilometres due east, and finally 20 kilometres due south. Calculate the distance and bearing of Nick from his original position. Now, I'm going to help with the diagram, and then hopefully you can have a go at solving. So he's doing a lot. So I'm going to start Nick right there. So I've got enough room to move. Nick cycles 15 kilometres north. So 15 kilometres, then 12 kilometres due east. Now, it doesn't have to be to scale, but I'm trying to make that line look a little bit shorter than the one I just did. I'm going to move that 15 kilometres. So it's out of my diagram. Now he's going 20 kilometres due south. So he's going an extra 5 kilometres past that other point. And it says calculate the distance and bearing of Nick from his original position. So if I draw from where he started to where he finished, that's the distance I want. And you should be able to see this right angled triangle here, which you should be able to find information for. Now the bearing is going to be that angle there. Hopefully you're seeing that if on that bottom triangle you find that angle there, you'll be able to work out that bearing. So my recommendation is from this diagram, redraw a bigger triangle so you can see what you're doing. This is theta, this is x. Now you know the entire distance is 20, and then so this whole distance here is 20. This one's 15. So you know this length here has to be 20 minus 15, which is 5 kilometres. So we have 5 kilometres here. And we also know that we have 12 kilometres across. And there's my right angle. So we've got hypotenuse, opposite, adjacent. If you did Pythag, then that would be C. So C squared equals A squared plus B squared. X squared is 12 squared plus 5 squared. It's 144 plus 25, which is 169. Now that's x squared. So x is the square root of 169, which is 13 kilometres. For our angle, O and A, so again, thinking of SOHCAHTOA, O and A is tan. So we have tan theta is opposite over adjacent, which is 5 over 12. So theta is inverse tan of 5 over 12. Go to your calculator, inverse tan, 5 divided by 12, and that gives me approximately 22.62 degrees. Now, I need the entire angle, so my bearing is going to be approximately 90 plus that 22.62 degrees. So that's approximately 112.62 degrees. Finish with a therefore statement. So Nick is 13 kilometres from his starting point at a bearing of approximately 112.62 degrees true. Now remember, what this question is asking is where is Nick from his original position? Okay, so what you're trying to say is if someone was at his original position, which direction and for how far would they have to travel to get to Nick, right? So it's from his original position. Next, two yachts sailed in a straight line from buoy B. One sailed 12 kilometres in the direction 38 degrees true, and the other sailed 16 kilometres in the direction 128 degrees true. How far apart are the yachts? Then the bearing of the first yacht as seen from the second yacht. Okay, so that's important there. So let's pull our information out. We have two yachts and they're from buoy B. One sailed 12 kilometres in the direction of 38 degrees true, and the other sailed 16 kilometres in 128 degrees true. So let's put our buoy B. Now, one sailed 12 kilometres in the direction 38 degrees true, so out this way. Again, doesn't have to be entirely accurate, just I suppose the more complicated we get, the more accurate we have to be. But I just think if you get the angles approximately right and you get the length of the lines relative to each other approximately right, you should be fine. So in the next one, which is 128 degrees true, I know that's 90 plus a bit more. So it's down this way. And when I draw this line, because it's 16 kilometers, I'm just going to make it longer than the line I drew previously. So this is 16 kilometers here, and that whole angle is 128 degrees. Using different colors can help. Um, Whatever works for you to make it clear, my biggest recommendation is a big diagram. Okay, so what we're trying to find is how far apart the yachts are. So we need this distance here. What you need to have is the angle in the middle here to be able to do that. And that's going to be 128 minus your 38, which is 90 degrees. What have I just discovered? I thought I had a non-right angle triangle, but actually it's right angle. So what I'm going to do, so it looks a little bit more accurate, I'm going to draw that triangle. So there's my 90 degrees. This is my 12. This is my 16. And that's my x. Okay, so that makes life a lot easier. So distance between is Pythag, c squared is a squared plus b squared. X squared is 12 squared plus 16 squared. It's 144 plus 16 squared is 256. Add those two together, we get 400. So that's x squared. So x is the square root of 400, which is 20. Okay, so I've got the distance between them. Now it's the calculated bearing of the first yacht as seen from the second yacht. Now this is where I'm going to go and label yacht 1 and yacht 2. So I know what I'm doing. So the bearing of the first yacht as seen from the second yacht. That's where you need to put that compass rose. So at the second yacht. So it's saying, if I'm at the second yacht, how can I get back to the first yacht? So I need this entire angle there. So hopefully you can see one key to that would be to find this angle here, which on that diagram I drew would be that one. So hypotenuse, opposite, adjacent, O and A. Tan theta is O over A, which is 12 over 16. Theta is inverse tan, 12 over 16. And that gives me approximately 36.87 degrees. So I've got that one. What I do need now is if I can find this angle here, and if you look at your diagram, you should see alternate angles. Okay, so that angle there is the same as that angle there. If the entire angle here is 128, and I know I have 90 degrees here, then that little angle is going to be 128 minus 90, which is 38 degrees. So that means this angle here is 38 degrees. So my bearing, we're going to have to go 270 degrees. So from here all the way around to there, plus the 38, plus the 36.87 degrees. And that is approximately 344.87 degrees. Okay, so this is definitely a complex question. Remember to finish for the therefore statement. We did have part A and part B, which I didn't separate. Now, the beauty of the videos is that you can watch it again. Okay, you can give it a go yourself. You can replay, and hopefully it becomes clearer. Okay, last one. A and B are two lighthouses, A being 20 kilometers due north of B. So I'm going to do that first. So this is B. 20 kilometers due north of B is A. The bearing of a ship is 145 degrees true from A. So from A, so I draw my compass bearing at A because it's from A. 145 degrees is down here somewhere. And it's 55 degrees true from B. So my compass bearing, my compass rose on B, 55 degrees is about there. Okay, so where these two intersect is where my ship is. Calculate the distance of each lighthouse from the ship. Well, I'm going to label the ship C. So then I can label my triangle like we're used to. So what the question is saying is what is A and what is B? Now I've got the 145 degrees. So this angle in here is going to be 180 minus 145, which is 35 degrees. So that's that angle. So that means my angle here is going to be 180 minus 35 minus 55, which is, yay, 90 degrees. I have a right angle triangle. Might not happen. You might have to use your sine rule or your cosine rule. And let's put our information. That's my 20 kilometers because this is A, B, C. This is my B and that's my A. All right, so now I just need to find the unknowns. So let's label opposite, hypotenuse, adjacent. Okay, now I could have labeled from the 35-degree angle. It doesn't matter. So I've got my H. Let's find A first. So A and H, so SOHCAHTOA. A and H is cos. So I've got cos theta is A over H. Cos of 55 is A over 20. I need to multiply both sides by 20. So my A is 20 cos 55. Go to your calculator and you get approximately 11.47. It's going to be kilometers. Now let's look at our other side, our side B. So we've got our hypotenuse and opposite. So that's going to be sine. So sine theta is O over H. Sine 55 is B over 20. B's being divided by 20, so we do the opposite and we multiply. So B is going to be 20 sine of 55, and our answer is approximately 16.38 kilometers, and finish with a therefore statement. Now, you may not always have right angled triangles. You know your sine rule, you know your cosine rule, so it doesn't have to be. The process will be the same no matter which way you go. You just have to figure out which is the best method of doing it. We will investigate more of that next week. You'll have a mixed lesson where we'll do a mix of sine and cosine and bearings. You'll also have a consolidation lesson next week, but you have these videos. So if you're struggling, rewatch the videos. I really emphasize the diagram is key. Remember when it's from, that's where you're doing your compass rose. Okay. But again, rewatch videos if you need to. It's just practice.